Well, thanks for joining the webinar today, everybody. Sorry about the little technical difficulty there. I'm going to turn on video for this one because today we're going to talk about physical stuff. We're going to talk about some actual things. I've got a bunch of examples over here on the desk, and so I'm pretty excited to go through some of those examples and things with you. Kind of a quick introduction after that excellent introduction from Letisa is my name is Joel, and I am the technical training manager here at Ekahau. I have a few certifications. Last year, I achieved CWNE, which is Certified Wireless Network Expert. Number 233 is a number that I got. The biggest thing that I learned from getting my CWNE is that I don't know anything about Wi-Fi. So also achieved the ECSC, the Ekahau Certified Survey Engineer certification, which I strongly recommend. I took that class from one of our excellent ECSC instructors before I actually joined Ekahau, before coming on board with the company, and months and months before that, even before that was even on the radar. And I can't recommend that course enough. Excellent class, excellent certification, and I highly encourage you to check it out after this webinar if you're interested in learning more about Wi-Fi and getting some formal training on Wi-Fi. A place you can reach me after this webinar is done. I'll be sure to put up some contact information at the conclusion here, but an excellent way to reach me is on Twitter. That's where the majority of the Wi-Fi community hangs out and talks, is on Twitter. So feel free to look me up on Twitter, but really it's not about following me, and just look at the people that I follow. Those are the smart people. Those are the ones that you really want to engage with and get involved with. I'd say probably 60% of what I know about Wi-Fi is from Twitter, and so I would highly encourage you to jump on Twitter and go check out the community there as well. A couple of housekeeping items here. Letisa went through a couple of those earlier, and it looks like PowerPoint is going to bring these in for me one at a time, which I avoid, but I didn't catch that before this when I put this deck together. I'm just going to hit next a bunch of times here. There we go. So a couple things to keep in mind. If you have any comments, please feel free to use the chat. And if you address those to all attendees and all panelists, then the other attendees can hear your comments as well. So if you have comments, go ahead and throw them in the chat. We'd love to see your interaction there. Also, if you have any questions, go ahead and use the Q&A tool. With the Q&A tool, you can input your questions there, and then those will be saved up for the end, and I will address those questions there one at a time. So be careful not to put the Q&A stuff in the chat. Go ahead and put that in the Q&A tool. That way I'll be sure to get that. I will probably miss it if it is in the chat. So we'll go ahead and do Q&A at the end of the webinar, and also this webinar is being recorded, and so about 24 hours after we're done with the webinar, our excellent marketing team here at Ekahau will get that posted to our website. I believe the URL for that is ekahau.com/webinars. And you can listen to this recorded webinar as well as any webinar from the past that we've recorded. So lots and lots of great content there. I highly recommend checking that out. So let's go ahead and dive into the topic at hand here, which is Wi-Fi tools. There are a lot of different tools out there, and it can be kind of difficult to know which ones you should use, what they're for, how to use them effectively, what kind of problems they can solve. And so that's what we're going to tackle in this webinar today. We're going to talk about all the different wireless tools and what you can do with them and how you can utilize them. So we'll go through all the common ones, really, like Wi-Fi scanners. We'll talk about Wi-Fi scanners and how they're important. We'll talk about spectrum analysis, both the hardware and the software side of a spectrum analyzer. We'll talk about packet capture and packet analysis as well. Probably just kind of a quick light touch on that. We probably won't spend a ton of time talking about packet analyzers. And then we'll talk about throughput testing tools and how you can measure real world Wi-Fi throughput. And there's some cool tools out there I'm excited to show you around the throughput testing side of things. And then, of course, this being an Ekahau webinar, we'll spend a bunch of time on using virtual design tools and site survey tools to both design and validate wireless networks. And at the end, we'll probably talk really quickly about some other types of tools like books and cabling tools and things like that. Just a few quick things I'll probably mention really quick. We won't spend a ton of time on that, but I just want you to be aware of some of the options that are available out there. So I think let's just go ahead and dive right in, and let's just start with the very first one. Let's start by talking about Wi-Fi scanners. Now, what is a Wi-Fi scanner? Well, a Wi-Fi scanner is a very simple tool that is going to show us what wireless networks are nearby. And so a Wi-Fi scanner basically uses a standard off-the-shelf Wi-Fi adapter. So it's going to be just any standard Wi-Fi adapter that's compatible with your operating system. And it's going to simply listen for beacons flying around in the air. Now, what's a beacon exactly? Well, a beacon is simply an access point's announcement of its existence. For example, here, if we look on my laptop, if we just click up here and look and see which networks are nearby, you're going to see a list of networks. And you can do the same thing on your iPhone or your iPad or your Android phone. A beacon is an access point announcing that it's there. So the way beacons work is access points about 10 times a second or so, they transmit this beacon frame. And the beacon contains the name of the network, what data rates the network supports, what type of security is in use. Lots of different things are included in that, but the most important thing is the name of the network. And so, for example, my little small office, home office access point here is simply transmitting every about 10 times a second, saying, "Hey, I'm Joel's network. I'm here." And then it does it again, and it does that over and over and over again. Now, this is really, really cool for us as wireless engineers because we can take advantage of this to use it as both as a design and troubleshooting tool. So a Wi-Fi adapter is going to passively scan for networks. Now, when I say passively, I mean that it's just going to listen for beacons. It's just going to see what is out there, and it's going to display that information. And it's going to give us that in kind of this graphical user interface, which is really nice. First off, we get a list of all of the nearby Wi-Fi radios that are transmitting. These are all access points or radios on access points. And then we also get a list of the SSIDs. We get a list of what kind of technologies are supported by that particular access point. Like, for example, mine here is a BGN device. And then we also get the channel number. So that's kind of the nice list view that we get from a typical Wi-Fi scanner. And then we're also going to get this graphical view that shows us the same information, but in a graphical format. I absolutely love this view because it really makes it understandable for us to see what's going on. So for example, we can see that right here on channel 1, each one of these squares is a wireless network. That shows us that, hey, there's a few networks here. There's one that's kind of down here a little bit. There's one that's a bit taller. And then there's one that's even taller than the rest. Well, what does the height mean? Well, the height tells us the signal strength. So we can see not only what channel something is on, but we can also see its signal strength based on its height. So all these networks that are over here, well, they all kind of have a low signal strength because their shapes are relatively short, and so they do not have a high signal strength. In fact, we can see they're at about negative 85 dBm, which that's pretty far down there. That's a fairly low signal strength. So we can see what channel they're on. We can see what their signal strength is based on the height. And additionally, we can see if they overlap with any other channels. So as you probably know, in the 2.4 gigahertz band, we only have 3 non-overlapping channels to work with. We have channel 1, we have channel 6, and we have channel 11. That's it. Those are the 3 channels that we have. We do have some other channels here, but the problem is that they don't have their own frequency space. They partially overlap with other channels. And that's bad because that's going to cause anything on those 2 networks to basically constantly corrupt each other's data and interrupt each other and cause retransmissions, which slows everything down. We don't want that at all. We want to avoid that as much as possible. So for example, this network right here that's on channel 9, he is partially overlapping with everybody on channel 6 and everybody on channel 11. And so that's a very poor place for the wireless network to be. So that would be it'd be a good idea for this network to move over to, I don't know, maybe channel 6. And so now we are simply sharing a channel with another network instead of partially overlapping. So that's one of the main things that you can see with a Wi-Fi scanner. So a Wi-Fi scanner shows us all the Wi-Fi networks, and it shows us signal strength, channel, and even when it's applicable, channel width, so we can see how wide each one of these channels are. And this is going to be used for a variety of tasks. It's really hard, and when I was putting this presentation together, I really couldn't single this down to like, okay, well, what's a couple of bullet points that you use a Wi-Fi scanner for? It's all over the place. Whether it's checking signal strength, picking a good channel for your network, double checking to make sure you've got good security in place. There's a lot of different things that you can use a Wi-Fi scanner for. It's probably one of the more flexible, more general Wi-Fi tools out there. So Um, so let's move on and look at the next related tool. And don't worry, I'm going to come back and demo these here in just a minute. We're not going to spend a ton of time in slides. I'm going to do a bunch of live demo. I'm going to turn the camera back on in a while. We'll do some live stuff in front of you. And so we're going to do minimal slides in this presentation. But let's move on to the next one. And the next thing that I want to talk about, which is very, very closely related to Wi-Fi scanning. Oh yeah, Stu says live demo. Nice. Yeah. Oh yeah. You know me, Stu. I'm all about live demos. The next is spectrum analysis. Now, this is very, very closely related to Wi-Fi scanning. Very, very closely. In fact, if you look at this screenshot of this is the real-time frequency monitor in Ekahau site survey, you'll notice that not only do we see we see a bunch of spectrum analysis view there, that's all the colorful stuff, we also see the Wi-Fi scanning view there. So this is pretty typical in a spectrum analysis tool to blend together both Wi-Fi scanning and spectrum analysis at the same time. And so, of course, we get that in Ekahau. Now, what's the difference between a spectrum analyzer and a Wi-Fi scanner? Well, remember that a Wi-Fi scanner just uses a plain old Wi-Fi adapter, a plain old chipset to scan for networks, basically to listen to see if there's any networks out there. Spectrum analysis is a little bit different, though, because it brings in special hardware. We're going to use special hardware to listen to raw radio frequency activity in the air around us. We're going to listen for basically anything that causes radio frequency activity, either in the 2.4 gigahertz band or in the 5 gigahertz band. So when we're using a spectrum analyzer, we're hearing more than just Wi-Fi. We're hearing anything that chirps: Wi-Fi, wireless video cameras, microwave ovens, cordless phones, baby monitors, Bluetooth devices. There's all kinds of stuff that talks in the 2.4 and 5 gigahertz bands, and spectrum analysis using special hardware shows that. And we can even see where that activity relates to our wireless network, because we get that Wi-Fi scanning overlay that shows us how those two things relate. So a spectrum analyzer shows all spectrum activity, including frequency. Let's talk about frequency first. Frequency being where in the spectrum the activity happens, whether it's down here on the lower end of the spectrum or up here in the higher end of the spectrum. We can see where that activity is occurring. Is it happening down near channel 1, or is it happening up here near channel 11, or maybe somewhere in between? So we can see frequency. Maybe we could also add, I'm going to attempt to draw with my mouse here, it's going to be horrible, but we can also maybe say channel, either frequency or which channel we're on. Next is amplitude. And don't let the word amplitude fool you. It's not a complex thing. That just means signal strength, or how loud something is. So when we look at a spectrum analyzer, if you see something that's really short, like a little spike down here, that's something that's kind of quiet. It's not very loud at all. Whereas if you see a really tall spike like this guy right here, that one is loud. It's really tall, so it's really loud. So amplitude and signal strength are basically the same thing. And that's something that a spectrum analyzer shows us, is how loud is the thing? How loud is it talking? The last one is utilization. Now, utilization tells us how often a channel is being used. How often is that channel being used by something? Now, remember, basically all radio devices out there have to share, right? They have to share time that they can talk on a channel. Really, in reality, only one thing can talk on a channel at a time, and that is especially true with Wi-Fi. On a Wi-Fi channel, only one thing can transmit at a time. So if you've got a few Wi-Fi devices all sharing a channel, they're all going to kind of bounce around on that channel, and they're all going to take turns talking. They're all just going to take turns accessing that channel and saying what they need to say. And fortunately, it happens quickly enough that as long as the network is well designed, don't worry, we'll get to that later. As long as the network is well designed, that's going to work pretty well. That's for us humans. We're not going to notice that our Wi-Fi devices are all taking turns talking on a channel. But what happens if you fire up, say, a wireless video camera that uses that channel 100% of the time? If we fire up something like a wireless video camera, maybe it makes a big spike in the spectrum, kind of like that. And don't worry, we've got some stuff that we'll play with here in a little bit when we do a live demo of this. But when we fire up a camera that uses the spectrum 100% of the time, that's not going to leave any time left on that channel for Wi-Fi devices to talk. Wi-Fi devices will look at the channel and go, oh, there's something talking, I'll just wait. And they'll just back off, and they'll just continually back off and wait for an opportunity to talk, because only one thing can talk on a channel at a time. And cameras, they don't care. They just don't care. They just don't care at all if something pops up on a channel and talks. And so watch out for that. That's something that a spectrum analyzer can show us is how busy is each channel? How often is each channel being used? If we look at a channel and we see, oh yeah, the channel's only being used about 10% of the time. Cool. That means we've got like 60% of that channel left for Wi-Fi transmissions. That's a good, healthy channel. If we see a channel that's being used 65 or 70% of the time, well, that channel's starting to get pretty full. There's not a lot of time available left on that channel. And we can also use it to identify and locate non-Wi-Fi interference. We can actually physically use that to locate interference in our environment. So let's go ahead and do that. So what I'm going to do here is let's go ahead and peel away into a live demo here. And so give me just one second to get kind of switched over to that real quick here. And there we go. Okay, it's cool. So now we are looking at Ekahau Site Survey, and we've got the Ekahau Sidekick connected right now. I'll turn the camera on real quick and show you the Sidekick. This is, I know that I'm probably a little bit biased here, but this is one of my all-time favorite wireless tools ever. I love the Sidekick. It's so cool. Okay, so this is the Ekahau Sidekick. It's basically a wearable, and as you can see, it's a little bit smaller than an enterprise-grade access point, and it's got an included shoulder strap, and so you can throw it. Over your shoulder, kind of like a messenger bag. It's got some pretty great hardware on board. It's got 2 enterprise-grade 802.11 AEC radios, and the primary function of those is for basically for Wi-Fi scanning. We'll get into the specifics a little bit later on, but they're mostly used for Wi-Fi scanning, which we end up using for site survey data as well. But the other thing it's got is a super duper powerful spectrum analyzer on board. Literally the most powerful spectrum analyzer in the Wi-Fi industry. And I know that vendors tend to make a lot of audacious claims and stuff, right? They tend to say, well, our solution is the fastest and best. I'm not kidding around. It's the undisputed king. And that's coming from the spectrum analysis side of me that loves spectrum analysis and just really enjoys this stuff. So that's the Sidekick. So I've got that one. I've got that connected right now. So let's go ahead and pop open the Wi-Fi scanning view that is in Ekahau. So down here at the bottom, there is this little pop-up button right here, a little up arrow. That's where we can view the Wi-Fi scanner and the spectrum analyzer that's included in Ekahau. So here we go. This is all live data in my environment right now that's coming from the Sidekick and my little access point and things like that. There's a couple things that I want to point out here. I'm going to pop this out into its own view so we can get a little bit closer look at what's going on here. And let's see, Terry says his Sidekick is coming today. That is awesome. I'm really stoked for you, Terry. I was really excited when I got my Sidekick as well. And I work for Ekahau. It was like, yes, got my Sidekick. So I understand your excitement. I totally get it. So let's take a look at what this looks like live in our environment right now. I'm going to start by hiding the spectrum analysis data just to get it out of the way. And we'll come back to that in a little bit. I just want to kind of concentrate on the Wi-Fi scanning data first. And so a couple things that we can see here. First off, Joel's network right here. Our signal strength is sitting at about negative 53 dBm. So you can see that up there. We can see that down here in the list as well. And then there's another network here on the same channel. You know what I think that one is? I think that's actually my Chromecast. And so if we turn the video back on real quick for a second here, I have, you could probably see the TV right there where my thumb is. I've got a Google Chromecast plugged in there, and it's broadcasting its own SSID as part of how the Chromecast system works. It broadcasts its own SSID even while it's associated to my wireless network. So we could see there's the Chromecast, there's Joel's network, and then there's Joel's guest network right there. So those are the 3 that are on channel 1. Way down here in low signal strength, we've got a few outliers. In fact, that one just disappeared. The signal strength is so low. Oh, and it's back now. That one is on channel 3. So if we were to sort to channel 3, yep, CenturyLink 6790 sounds like probably one of my neighbors has just their little customer premise equipment that they have hanging out here on channel 3. So let's go ahead and turn on the spectrum analysis data now. And I'm going to turn on the waterfall view here so we can get that view as well. And let's talk about what we are seeing here in the spectrum. What's all this stuff that we see going on right now? Now, things are going to come and go, and I'm going to use what I have here as an example. The first thing I see is all these little spikes everywhere. Notice all these tall green spikes that keep randomly popping up all over the place. Down in the waterfall view, those spikes are also these little dots, these little red dots that show what is happening over time. all of those little spikes, each one of those is a Bluetooth hop. From my Bluetooth mouse and keyboard. And so if you look on my desk here, I've got an Apple Magic Mouse and a wireless keyboard. These are Bluetooth devices. I've also got an old Pebble smartwatch on. You can't see it because of my hoodie, which is the official Ekahau hoodie, by the way. Those are all these little spikes in the spectrum are all hops from my Bluetooth mouse and keyboard. The other thing that we're seeing is right here on channel 1 is this curve shape in the spectrum. Notice that it's perfectly lined up with the center of my wireless network channel. That curve shape is an 802.11b transmission. And so there's something talking on that channel using an 802.11b data rate. And so that's just one of the things that we can see there. If we switch our view over to the channels view, we can see that our spectrum utilization, well, right now is basically 0. Let's look at a longer time span, maybe 60 seconds worth of data. Looks like over the past 60 seconds, the average utilization on channel 1 is about 3%. Now let's skip up to the 5 gigahertz band and see what we can see up there. So I'll switch up to the 5 gigahertz band mode real quick here. So I'll just take a second for Ekahau to make the switch. There is quite a bit of there's quite a bit of data coming in here. So. Okay, so here we go. We've got, let's bring back our waterfall real quick here. And let's take a look at what's going on in our environment right now. What is actually happening here in the 5 gigahertz band? Well, if we zoom in on this channel, we can see that I'm actually running an 80 megahertz wide channel here, and we can see all of the activity on those channels right now. So if we go back to the channels view, we can look and see, oh no, demo fail. Getting beach balls again. It's probably because I'm running a virtual machine and a bunch of stuff in the background right now, but we're looking at about 4%, 3 to 4% utilization right now. So yeah, that's just kind of a cool look at, how busy is that channel? What's going on those channels right now? And that's all Wi-Fi right there. But what about stuff that's non-Wi-Fi stuff? What can we do for non-Wi-Fi stuff here? Well, I have a little toy here. This is something that my pal Jerry Ola here at Ekahau got for me. This is a little wireless video camera, and I want you to watch what happens when I plug this bad boy in. This thing is a lot of fun. So if we plug it in, we can see this shape pops up right here between channels 100 and 104. That is this little wireless video camera. And if we turn our time span back down to about 5 seconds, we can see that the color here, color indicates how often something is talking. If you see green, that means it's a really short signal. If you see red or black, that means it's a constant signal, kind of like an air horn. And so luckily there's nothing on channels 100 or 104 up here. I made sure that I didn't want to be on the same channel as this while I'm presenting to you over Wi-Fi. That'd be a terrible idea. Yeah, I've totally jammed myself while giving a webinar before. Bad idea. But anything on channels 100 and 104 is going to have a bad time right now because of this device that is transmitting on those channels. So that's what I wanted to show you on the spectrum analysis front. So with that, let's switch gears here. And let's move on to talking about the next tool that I have in my toolkit. So starting with a Wi-Fi scanner and a spectrum analyzer, coming from the Sidekick. Lots of options out there, but this obviously the Sidekick is by far my favorite one. I love this device. The spectrum analyzer on it is just awesome. The next thing I want to talk about, though, is packet capture. And so you could say either packet capture or packet analysis. Packet capture being the process of actually collecting the data. So how do you get a packet capture? How do you get that? Well, you're going to capture all Wi-Fi traffic from a specific channel. So what we can do is we could take a standard Wi-Fi adapter. I don't think I have anything in reach here, but if we could take a standard Wi-Fi adapter and tune it to a specific channel and just grab all the packets that we hear on that channel. An excellent packet capture device is actually a MacBook. It's one of the reasons why I use Mac OS. Don't worry, I have an Android phone. I'm not a total Apple fanboy. I do think that there's some great products on both sides. I love all that stuff. But MacBook makes an excellent packet capture tool. And to do that, if you look on my screen here I have to turn off annotations first. Duh. Okay, there we go. There's an excellent tool out there called AirTool. This is by our good friend, Adrian Granados. Adrian is a good friend of ours. And if you just Google AirTool, you can go find this tool. And this will allow you to get a packet capture on Mac OS with no additional hardware, which is pretty rad. And then you can take that packet capture and you could bring that over to a packet analysis tool of your choice. Now, one of my favorite packet analysis tools out there, if I can find the right desktop that it's on real quick here, is Wireshark. Wireshark is free and open source, and it'll display all of those packets that you just captured. And so this is a packet capture that I did earlier. I'm kind of using my Wi-Fi adapter to give you this webinar right now, so it's probably not a good idea for me to do a live packet capture in front of you. But I did this just a few moments before joining the webinar, and so we basically get this list of packets that we captured, and we can look at that conversation to see what happened. In this case, I just ran a Ookla speed test between my phone and my little DSL modem and gateway that's downstairs. We just moved into the house, haven't had time to set up my network yet, so cut me some slack there. But we can see the conversation that my phone and my little wireless gateway had. And so you can see where we transmitted some data and then we got an acknowledgement back. We transmitted some data and got our acknowledgement back. And one thing that I'm noticing here when I'm looking at this conversation is that we transmitted data and then we had to retry transmitting the data. It transmitted the data the first time and never heard an acknowledgement, so I had to transmit it again, and it had to transmit it again. And so maybe there's something going on there. Now, if we filter out for retries, I'm just going to apply this filter here. We can see that out of all of our packets, about 5.3% of them were retries. And so, you know what? That's okay. If it was 25, 30% retries, I would say, man, why are we having to retry with all these transmissions? Maybe there's some interference. Maybe there's something going on there. But this is gonna, but this is a great way to look and see, on a packet by packet basis, what does the performance of our network look like? Another tool out there that I really love is a tool by our good friends over at MetaGeek, which is IPA. IPA is kind of fun because it breaks packet analysis down from an airtime usage standpoint. How often did things consume the air? So go check that out. Great tool. Love it. But that's another webinar for probably for another day. Okay, cool. So let's move on from packet analysis. And let's go take a look at the next thing that I wanted to show you today, which is virtual network design with Ekahau. Now, this is something I get really excited about. I love Ekahau, and I love the virtual design tools in it. But first off, what is a virtual network design? What is it? Well, a virtual network design is when we think, oh man, PowerPoint is letting me down real bad today. Actually, it's my fault. I shouldn't blame PowerPoint. I didn't set up the slideshow correctly. Virtual network design is also known as predictive modeling. That's when we're going to create a model of a wireless network. And so we're going to basically simulate the wireless network. Now, this is really great because you can perform a wireless network design without spending a ton of time on site. You don't have to spend days on site moving around access points, figuring out where APs should go, figuring out what their transmit power should be, figuring out what the channel plan can be. You can go inspect the building, kind of see what's going on in the building, and then take all that data back and input that into a predictive model, a virtual network design. And you can use that for a lot of different things. You can use that to create wireless network designs, and that's going to include determining the correct number of APs, not too many, not too little, determining where the access points should go, and determining how they should be configured, what channels they need to be on if you're using a static channel plan, things like that. So let's go ahead and you guessed it, let's do a live demo of a virtual network design. So, okay, here we are in Ekahau, and I'm just going to start a brand new project file here. So this is an existing one that I was working on earlier, but let's go ahead and just start a brand new file, and we need to bring in a map first thing. So I'm gonna add a map here. And just kind of for the sake of time, I'm going to bring in a CAD file, a DWG CAD file. Now, you can bring in like a flat image file, like a JPEG or a PNG or a PDF or something like that, but the CAD file is going to speed things up a lot. And plus, I just want to show it off because it's really cool. So Ekahau is going to load up that CAD file. First thing. Question from Matt that's very applicable for what we're talking about right now is, can you use Visio drawings or only AutoCAD? Specifically, Matt, the type that we support is going to be a DWG CAD file. And we chose that because it's a pretty broad type of format that you should be able to get out of most tools out there. Most things like Revit should be able to export a DWG CAD file. I'm not an expert in the CAD side of things, but my understanding is that's a nice, it's kind of an open format that you can get from a lot of different applications. So I'm going to switch from this kind of print layout view in the CAD file to just the model. I just want to get rid of all the extra print stuff that I don't care about. So we'll load that up real quick. And then I'm just going to go through and tell Ekahau what all the different materials, what all the layers in the building represent. And so the doors, we'll say that those are 6 dB solid wood doors. For the elevator shaft, we'll say that that's a 30 dB elevator shaft. For the exterior walls, we'll say that this is a brick wall. So we'll do a 10 dB brick wall around the outside. For the stairs, we'll line the stairwells with a 5 dB cinder block wall. And then for the interior walls, we'll do a 3 dB wall. So there we go. We've now told Ekahau what the building is made out of. So we'll import this design really quick. And now Ekahau is going to go through and give us a bunch of really useful messages about exactly what it's doing right now. So let's see what it does here. This can't be right. Trying again. Removing outer space walls. You got to get rid of those. The only one of these messages in here that's true, by the way, is wasted 80% of our developer resources to write these. That's the only one that's true. And I guess saving 16 hours of mouse clicking if you have to manually draw in walls, which isn't that big of a deal, by the way. Okay, so here we go. We've got our walls all drawn in here. Now, one thing I do recommend doing is if you can go on site and take a portable access point with you, it doesn't even need to be the AP that you are going to deploy, and measure some of these walls. See how much loss there is from one side of the wall to the other. That's a great use for a Wi-Fi scanner. Check and see how much signal strength do we see knocked down as we move from one side of the wall to the next. Okay, so let's go ahead and define our area where our network is going to be really quick. Now, one thing I'm going to do here is I'm just going to be really quick about this. I'm not going to take a ton of time to go get all the little corners and things like that. This is just an example for a webinar, so we're just going to be quick here real quick. So we'll go through quick. We're going to be quick real quick. What? Come on, Joel. So now let's go ahead and get our area drawn in there. So there we go. And now we can choose an access point and start placing APs on this map. So I'm just going to pick a random one. I'm going to go for an Aruba 225 today. Yes, yesterday it would have been Cisco. Day before that it would have been Ubiquiti. So we'll go ahead and place an AP here. And I'm just going to go through and basically place access points until we have some decent coverage in this environment. Now, remember, this is a predictive model, and so this is being simulated in Ekahau right now as I place these access points. Now, this is one way that you can plan for coverage. The other way, there's a super cool new way that the guys just put in, our development team just got in here, which is the coverage planning tool. I love this because basically you can just hover your mouse around and it'll give you basically real-time feedback of what coverage looks like in the environment. So, and to make sure that things are nice and quick, I'm actually going to turn off video for a little bit. Don't worry, we'll bring it back here in a little while. Okay, so there we go. We've got all of our coverage in here. Let's go check on our signal strength visualization again. Signal strength isn't everything, but it's important for sure. So there we go. Looks like we've got some signal strength. But the real thing that I'm curious about is, are we passing requirements or not? Are we meeting the requirements for a good Wi-Fi design? So if we go look at network issues, let's see how we do. Ooh, okay. Well, it turns out that anywhere that there's color here shows us that there are some issues with this wireless network. The worst one that I'm seeing here is channel overlap. Notice it's the pink or magenta color here. We've got some pretty severe channel overlap here. So let's see if we can fix that. So if we go look at the channel overlap visualization, we can see that, anywhere that's gray is where we have 2 or more access points sharing the same channel. And if you remember, only one channel can talk, or only one device can talk on a channel at a time. So having a bunch of APs on the exact same channel, that doesn't help at all. It's not good Wi-Fi. So we need to fix that. Now, what we could do is we could go through and do a manual channel plan on this. We could go, okay, well, this one's on 36, so we'll put this one on 40, and then we'll put, this one on 44, and we could go through and manually plan out the channels of this wireless network. But why would we do that? We got computers to do this stuff for us. So what I'm going to do is I'm going to run the channel planner here. And we could say, tell it whether we want to use 20 or 40 megahertz channels. I think I'm going to use 40 megahertz channels here, but I'm going to disallow channels 132 and 140 and 144. Maybe there's some neighbors that are on that channel already. Maybe we have a client device that does not support those channels. So we'll hit create plan, and Ekahau will go through and rearrange all those channels for us. So now let's see how things look in the 5 gigahertz band. Oh yeah, beautiful. And let's go take a look at our network issues and see, okay, things look okay, but there's still kind of some coverage areas here. Anywhere that's yellow is where we only have one access point covering those areas. There's no second access point for things to fall back on. So I'm just going to go ahead and up my AP density a little bit here by adding a few more APs. and we'll take care of that little dead spot right there. And we have reintroduced some coverage or some channel overlap. So I'm going to run the channel planner one more time here. So we'll just run that again. And you know what? I think that looks pretty good. That's kind of, that looks like the basis of a decent network design. So let's see how we're doing from a requirements standpoint. How often are we meeting requirements? Well, looks like we're meeting requirements on 92% of our floor plan. And so that is looking like that, that could be a good design for our network. So I hope that gives you a good idea of what a virtual design tool does and how that can help you plan a wireless network without having to go on site and spend a ton of time on site. I do recommend some on-site time, to figure out what the building looks like, see what all the materials of the building are, and measure a few walls and, know how tall the ceilings are and things like that. It's a good idea to go on site for those kinds of things. But you can really, really knock out a design really quickly with a virtual design tool. Okay, so what's next? Next is a passive site surveying. Oh, I have a typo right here. Ignore that. That is a total typo. I totally missed that. But a passive site survey is where we're going to actually go on site, and we're going to actually go on site and we're going to take measurements of a wireless network. So we're going to actually look and see what the real world coverage looks like. Now, remember, a moment ago, we just did a predictive model, right? That is a prediction of the wireless network. Man, I really screwed this slide up. Look at that. All kinds of stuff. Oh yeah, actually it looks like I never even got around to filling this slide out. I got the image in here, but I never replaced it with the right stuff. That's okay, we'll wing it here. So what we're gonna do is we're gonna go on site and we're going to take real world measurements of the wireless network to see what the coverage actually looks like. How does the network look like in the real world? We did our predictive design, we got it close, but we need to go validate the network and make sure that it's actually achieving the requirements that we have set for it. So here's how we do a site survey. So I'm just going to start with a fresh project file here, and I'm going to bring in a map. So we're going to use the same map that we used earlier, but this time, since we're just gathering data, we're not going to bother with any walls or anything like that. I'm just going to go ahead and select the correct background map that I need, which is this map right here. And then we're just going to hit the import button. We're not going to worry about drawing in walls or anything like that, because this time we're just going to go collect data. There's not going to be any predictions done here. It's just going to be strictly data collection. Okay, so we have our map here. It's all ready to go. We're going to switch over to the survey tab. And let's start out by conducting a continuous survey. So we've got our Sidekick on. It's slung over our shoulder and it's plugged into our laptop. We've got our laptop in hand. We're going to walk all over this building and take measurements all over the place, and that's what's going to be used to draw our real world data to validate the network, to make sure the network meets the requirements that we have set for it. So I'm going to start in the lobby here. I'm going to stand here in the lobby, and I'm going to click, and I'm going to start walking, and I'm going to walk in a straight line at a consistent pace. While I walk, the Sidekick is going to be gathering data points in the background. It's going to be gathering all those data points for us. As soon as I come to a corner or some place where I need to turn or change directions, right as I get there, I'm going to click on that spot and then sharply change directions. We'll walk across the hallway here, and then we'll click there, and then we'll head back down here towards this reception desk. So all you have to do is click whenever you change directions and just walk at a consistent pace. And so all those data points can be nice and evenly spread out. So typically what I do is I'll walk down one side of the hallway, back up the other side of the hallway, and I'll just kind of crisscross and zigzag all over the place until I've gotten data points for the entire map. And I'll show you a completed survey here in just a moment. The other type of survey is going to be a stop and go survey. So a stop and go survey is useful for smaller, more enclosed spaces. Think classrooms, think hospital rooms, things like that. Places that are kind of hard to get in and out of and hard to navigate in a continuous fashion. I really like the stop and go survey for small enclosed spaces. With a stop and go, you're just going to go stand somewhere, just stand there, and click on the map while where you're standing, and the Sidekick will take a data point while you stand there. And then as soon as that's done, you'll move on to the next place, click again, it'll take another data point while you stand there, and rinse and repeat over and over and over again until you have all of the data points that you need to draw a map of your real world wireless coverage and see whether your network is meeting requirements or not. So this is obviously bad data because, if you were looking at the video earlier, you can see that I'm just sitting at my desk right now. So none of this is good data. So let's just go take a quick look at a completed site survey. This one's a couple years old now, but it'll work just fine. So this is a look at a completed survey here in this building. You can see where I did continuous surveys and kind of walked around all over the place, up and down each side of every hallway, and where I did stop and go data points in all the classrooms and places like the gymnasium, which was full of stuff at the time, kitchen, places like that. And so I really like the ability to mix continuous mode surveys and stop and go surveys. And then when you're done, here's what you get. Let's take a look at how our coverage is for our network. If we look at signal strength, hey, signal strength looks pretty good. If we take a look at our network issues, did we meet all of our requirements for our network? Let's see how we did there. This is exactly the same view as we saw when we did the virtual design. We can see that we're passing requirements for the most part, although we've got some areas where we're failing our number of access points requirement. We've only got one AP covering these areas, and so we're failing that requirement in those areas. So maybe we need to do some work there to see if we can remediate that problem and get things kind of fixed up a little bit. Okay, so there we go. That's what I wanted to show you on the passive site survey side. The other thing I want to talk about is an active site survey. Now be careful here. There are two main types of survey in Ekahau. There's both the passive survey, which we talked about just a moment ago. That's the most important type of survey. That's data that's drawn. That's all data that comes from beacons from access points. And while it doesn't sound very exciting, it is by far the most important type of survey. The active site survey is more of a nice to have. It's kind of a bonus that you can get. And there's two types of active survey that you can do. You can either do a throughput test or you can do a ping test. Now, a ping test is where we just take a normal, standard, off-the-shelf Wi-Fi adapter. Maybe it's the adapter built into your laptop that you're surveying with. Maybe it's an external USB adapter. But that is going to just ping a host out on the network somewhere. And that's going to get us round trip time and jitter and packet loss. And so we can see, how smooth things are on the wireless network. And then the other type, which I'm going to focus on here, is the throughput test survey, which is just another type of active site survey. This is where we're going to perform a throughput test using a tool called iPerf. Now, iPerf is built into Ekahau, and so we're going to basically just point Ekahau at an iPerf server, and it's just going to stream a ton of data across the air as fast as it can, and that way we get a real-world look at what the network throughput and network performance looks like. So I'll show you really quick how to configure that in Ekahau, what that looks like. I'm not going to fire one up here today because I don't want to mess up our webinar, but I'll show you what that looks like. If you just go to the throughput test here, and this is my internal adapter on my Mac, and then we can just basically go point it at an iPerf server, like, maybe on my local network here, maybe be 192.168.0.51. If that's where my iPerf server is, then it will begin performing that iPerf throughput test. So remember that iPerf is open source and readily available on the internet. But we do have our own implementation out there called ePerf. Now, the reason why we came up with our own implementation of it is because, iPerf is not very good at handling breaking and reconnecting sessions. When you roam from one access point to the next, that tends to break iPerf. And so we came up with our own completely compatible implementation called ePerf. And you can just Google that and go grab a free copy from our website. Or you can use this sweet little box that Jerry here from Ekahau came up with. This is actually what Jerry looks like, by the way. That's a real photo of Jerry. Jerry is one of our product managers here at Ekahau, and he came up with this sweet little box called a WLAN Pi. It is based on the NanoPi single board computer. And he basically came up with a custom image that you basically write an image to an SD card and plug that into the NanoPi, and then the NanoPi starts up an ePerf server and then displays the IP address of the server right here on the screen. So you can basically drop that next to your switch, plug that in, and point Ekahau at it once it displays the IP address, and there you go. And so you can find out more about that little box at WLANPi.com. And so let's take advantage of the camera real quick, and I just want to show this device to you. So this is what it looks like. And here's mine. Here's mine running right now. So you can see it's displaying currently. It has no IP address because there's no Ethernet connected. But it'll also run on a battery pack pretty much all day. So this is great because you can just go drop it in a server closet somewhere. I love it. It's super cool, and it does a lot more than just this throughput testing thing. By the way, there's a lot more. Just Google WLAN Pi, and pretty cool little project that Jerry came up here with here. So. Cool. So what I'm going to do now is let's just kind of finish up by talking about some other tools and things that I really like. Before we get into the book, we'll hold off for a second on that. But some other tools that are really important. I like to think of. There's a lot of tools out there that pretty much every wireless network engineer has to have, right? And I think all the tools that we've talked about today are really important ones to have. If I was an engineer, and even though I'm totally not like a mechanical engineer or something like that, one of my most important tools to have at my desk is a set of calipers, right? Well, if you were going to have a set of tools for wireless, what tools are so important that you absolutely have to have them? When we talked about Wi-Fi scanners, we talked about packet capture tools, we talked about spectrum analyzers, we talked about site survey and network design tools. Some other ones that are really important is, like it or not, we are building infrastructure on top of wired infrastructure, right? And so you need tools to support wired infrastructure. Like, for example, you need something to crimp down cables. Buying a decent crimp tool, this has just saved me tons and tons of work. And this goes all the way back to my Ethernet cabling days. Is having a good punch down tool for punching down Ethernet jacks and things like that. It's amazing how often wireless issues come back to issues with the wired infrastructure. Things like a cable tester are very, very important to have. And so I strongly recommend having those tools on hand. Another great tool to get to the book thing is there's some awesome books out there that I really want to recommend. The first one, I'll come back to what's on screen here in a second, but the first one, this is a brand new, just freshly minted copy of the CWNA study guide. This is a study guide for the Certified Wireless Network Administrator. This book is brand spanking new, hot off the press from David Coleman and David Westcott, and tons of my friends put a lot of effort into this book. Look, it's massive. It's absolutely huge, but this is what I consider to be the Bible of Wi-Fi. I still reference this book all the time. And of course, this one is brand new, so it looks all nice and fresh. But you got to have a copy of the CWNA on hand, and I can't recommend the 5th edition enough. This is the most comprehensive thing out there yet. If you want something a bit lighter, something a bit easier to read, this little guy right here, the Wi-Fi Network Design Dummies book, brought to you by Ekahau. And so this is a project that we at Ekahau put together a few months ago. You can get a free PDF copy from ekahau.com/dummies. And so be sure to go grab that. If you want something kind of light reading that you can kind of go through some important Wi-Fi concepts really quickly without having to go through literally, is that a 3.5-inch thick book? It's massive. This is a great little condensed way to go through that. So go grab that. We're really proud of this. We think it's pretty cool. Okay, so let's go ahead and kind of move into kind of Q&A things. So as you're thinking about your questions and things like that, here's some next steps for you to consider. If you want to learn more about Ekahau Site Survey, the best way to do that is to schedule a demo with one of our technical solutions architects, whether that is Nick Turner over in the UK or Clayton Matthews here in North America. These two guys are incredibly smart and excellent presenters. And way more organized than I am, and they can walk you through Ekahau and answer any questions that you have about it. And you can also request a free evaluation license at this URL right here. So with that, I think we should go ahead and move into Q&A. So let's do that. So go ahead and put your questions in the Q&A tool, and we'll go ahead and work through those. So I'm just going to kind of start at the top and kind of go through some things here. Let's see. Okay. So a great question from Atef is, can the spectrum analyzer pattern be categorized to help identify what or who is using the spectrum? That is a great question. So the answer is yes, you absolutely can categorize these. Now, in Ekahau right now, we have been working on an experimental feature that would do automatic signature detection for you. Once you spend some time with a spectrum analyzer, you get to the point where you look at something, you go, that's a wireless video camera, or that's a cordless phone, or that is microwave. You get pretty good at recognizing what those things are, but it's a bit of an uphill battle to get to that point. And so that is an experimental feature in Ekahau right now. We could talk about that one a little bit more offline if you would like. The team is still working on that, making good progress on it. It's a very tough problem to solve. That's for sure. Let's see. So a question from, not sure if it's Jan or Jan, is, can you show how to read utilization in the spectrum analysis view? So yeah, that's a great question. Let's go ahead and take a quick look at that. So if we pop open our copy of Ekahau here, and let's just go take a look. Oh, I still left my camera running. I guess it doesn't matter. It's not hurting anything. If we go down here and look at my 80 megahertz channel here and see what's going on there, I'll turn off the video so we can get some good video performance here for my screen share. We can see that channel 36 is being used about 2% of the time right now. Now remember, this is over a set time span. How long, we're kind of looking at a time span here. And we can see that over the last 5 seconds, we're seeing somewhere between 3 and 4% utilization. Maybe we should bump it up to 120 seconds or 2 minutes. And Ekahau will calculate, what the utilization has looked like over the last 2 minutes. So it looks like about 4 to 5% on all 4 of those 20 megahertz channels. Now, I think I saw another question in there about how is that calculated. It's basically an average across the channel. So the spectrum utilization value is a good measurement of how often is it busy, kind of from an 802.11 standpoint, from a Wi-Fi standpoint, how busy on average is that channel on the network. So hopefully that kind of answers that question for you. Let's move on to the next one here. Ekahau site survey, is it compatible with Linux or does it work with Wine? Jeff, as a longtime Linux fan, I'm definitely I've always been like a perpetual Linux newbie. I'm the kind of a guy that uses Ubuntu and things like that. But unfortunately, no Linux compatibility at this time. And I have no idea whether it'll work in Wine or not. But good question for sure. My preferred platform right now is Mac OS because I like having pinch to zoom and things like that. So let's see. Let me just look through and see these questions, see what some questions are that I can answer here. Okay, so either Jan or Jan, I'm not sure how your name is pronounced, Jan or Jan. Sorry if I'm messing it up. There's a good chance I'm not even getting it right at all. What if you have an industrial complex with many metal objects? How do you get those dB losses into the virtual design? That is a great question. Excellent question. Very pertinent to this discussion. Here's how I do it. Let's say that there's a wall right here. So there's our wall, and we want to know how many dB of loss there is in that object or in that wall. What I'm going to do is I'm going to set up an access point about, I'm going to set that access point up about, I don't know, maybe 15 feet away or maybe about 3 meters away from the wall that I want to measure. The reason why I'm going to give it some separation is that signal strength tends to kind of jump around all over the place. Even little tiny adjustments in your position can see a big change in signal strength when you're really close to an AP. So if you move about 3 meters away, that kind of makes the signal strength settle down and be a little bit easier to measure. Then take 2 measurements. Take your signal strength measurement on the close side of the wall. Maybe we see negative 45 dBm. And then on the far side of the wall, maybe we see negative 55 dBm. You're just going to use Wi-Fi scanner for this. The Wi-Fi scanner that's built into Ekahau with the Sidekick is going to work great. That's going to be a 10 dB wall. And so then all you have to do is just go into Ekahau and edit that wall type, and it will change all the walls across the entire design that are that material type to 10 dB. And so, if you had a bunch of drywall in a building, you could draw them all in ahead of time and then go on site and measure those, and then just go back to your predictive model and just change that preset from 3 dB to 10 dB or whatever it is, and it will change them across the entire design. So I highly recommend doing that. That's a great way to make your predictive models even more accurate. So lots of questions. I don't know if we're going to be able to get through all these, but I'll do my best here. Let's see here. Just kind of scrolling through here. Tara has a question. Can you do multi-level predictive modeling with multi-floors? Absolutely. Yeah. Unfortunately, we didn't have time to get into that today, but Ekahau predicts everything in 3D. It's all done in 3 dimensions. And so you can do multi-floors and you can stack up floors and see how RF propagates from floor to floor. It's really cool and lots of fun. Too bad we didn't have time to jump into that today because I would have really, really liked that. Question from John, can it do DWG and DWF files? I think, John, we're limited to DWGs. I think that's where we're at is DWG files. I don't know if I have never had a DWF to try, but we can definitely get you an evaluation license if you'd like to give it a shot and see to see if it works. So Christian has an interesting question. This is a very interesting question, and I have opinions on this. If you don't agree, that's okay. That's fine. Are there any advantages to drawing walls before surveying? Very valid question. So you probably noticed that when I did my predictive model, I drew walls. When I did my survey, I didn't draw walls. I kind of like to keep my predictive model as a predictive model. And so that gets all the walls and the predictive stuff going on over there. But when I do a survey, I like to keep that in its own file and keep it separate. I like that to not have any predictive elements in it, just survey data. And so there are some corner cases where it makes sense to draw walls in on a survey. Let's say, for example, that you are surveying a hospital and you absolutely cannot get into the patient rooms. They will not let you into the hospital rooms. You could draw in the walls and then survey the hallways, and then Ekahau will do a prediction of what that real world signal strength is going to do as it passes through the walls. Is it an optimal solution? No, it's not, but it can help. And in that case, I would simply make sure that the customer understands, hey, I'm surveying the hallways, but since you won't let me into the patient rooms, we don't know for sure what the patient rooms look like. This is just a guess. I can't guarantee anything in there. That's how I would do it. So you can see how there's kind of a corner case where it kind of makes sense. I usually don't mix those two things together. I usually keep them separate. Matt says, what is considered the best first certification for wireless? That is a great question, Matt. I'm going to limit it down to 2, and this is my honest opinion on this. It's going to either be the CWNA, Certified Wireless Network Administrator, or if you're doing design, if design is a big part of what you do, the ECSC, the Ekahau Certified Survey Engineer. The CWNA is great because it's a good overall, it's just a really nice wide net over all things wireless. The ECSC is great because it is a 4-day boot camp in which you learn how to design and deploy wireless networks. What I love about it is it's not so much of a here's how to click on things in Ekahau class. It's more of a here's how to design and deploy great Wi-Fi class, and learning how to use Ekahau is a natural byproduct of that. So CWNA or ECSC, I absolutely love them. So let's see. Next question is, Vicky says, where do you buy a WLAN Pi? That's a really good question. Go to www.wlanpi.com to get some more information about it. As far as purchasing one, I think Keith Parsons sells them on the Wireless LAN Professional store. So go check that out, wirelesslanprofessionals.com or some variation of that. Maybe it's wlanpros.com. I think it's wlanpros.com. It's not expensive. It's like $70, something like that for the kit. You get a cool little kit that you get to put together. I like it. I think it's super cool. Really, really makes the geek in me very, very happy. So Fariz has a question about what's different about using an Ekahau adapter for doing surveying versus a built-in adapter. So right now with Ekahau, there's basically two main ways to gather site survey data. There is the Ekahau Sidekick. That is our primary method right now. This is the 2 radios on board, gets us really fast measurements. I really, really like the Sidekick a lot. Kind of the older way of doing a survey was to use USB Wi-Fi adapters. So we still offer these. This is the Ekahau SA1 survey adapter, this little guy right here. You can use these for surveys in Ekahau. Not going to be as fast, not going to be quite as accurate, but they're still a perfectly valid solution. The advantage to using either the Sidekick or the USB survey adapters is we have complete control over these, even more so over the Sidekick. But for this discussion, we have control over these. Your built-in adapter on your laptop, typically we don't have direct control over it. We don't have the ability to use special drivers with it. And so it basically gives us more control to do faster and more accurate scanning. So that's the big difference. I hope that's a satisfactory answer. That's kind of a big discussion kind of off on its own. So we'll go for another 5 minutes or so, and then we'll go ahead and cut things off. We'll go ahead and cut things off here and let everybody get on with their day. But we'll have about 5 more minutes of questions here before we call it good. So let's see. Question from Gerardo is, do you guys have spectrum analyzers? Maybe the one that you showed that can analyze other bands, for example, 433 megahertz? Unfortunately, no. The Sidekick is very much purpose-built specifically for Wi-Fi. So it does spectrum analysis in 2.4 and the 5 gigahertz bands. Fortunately, no other bands outside of those are supported. For those other bands, I would recommend maybe picking up like a cheap RTL SDR adapter. That would be a good, it's going to not be nearly as easy to use. It's going to take some setup time and things like that. But if you really want to get a low-cost spectrum analyzer in the 433, that's the way that I would go. I think that would be a good idea. Carlos has a good comment here. Is there a point where 2.4 gigahertz channels are completely useless? For example, 10 wireless LANs are on the same non-overlapping channels. Yes, Carlos. There are environments where there's so much congestion, there's so much interference, there's so much channel overlap in the 2.4 gigahertz band that it is no longer suitable for use. If you see, there's really, it's not like how many APs are on the same channel. Typically, I shoot for 3 or less on the channel, but really, in my opinion, what it's more about is channel utilization. How often are the channels being used? You know, if you see 10% utilization, that's pretty clean. There's not a whole lot going on there. You see 70% utilization, no, it's done. There's absolutely nothing left on the channel. And that is why having a spectrum analyzer is so important. Just knowing how many Wi-Fi networks are on the same channel, it's a start, but really we need to know how busy is that channel? How often is that channel being used? And that's something that a spectrum analyzer gives us. And so that's why I love the Sidekick, because I can actually see that. Okay, just a couple more questions. Question from Chris here. When creating a predictive survey, how important are the office doors, and do you create the plan with them closed or open, since most office doors are open? Or closed, I think, actually, is what you meant there. Good question. Should we do the predictive model with doors open or closed? I'm going to give the Sam Clements answer here. It depends. Are the doors typically open or are the doors typically closed? I will use that method that I talked about earlier to measure a couple of doors and see if they're different than the walls. If they're not significantly different than the walls as far as loss goes, I won't even bother drawing them in there. You know, obviously with the CAD import that I showed earlier, that gives us a nice, that goes in and draws them in all for us. And you notice that Ekahau even closes the doors for you. It actually went through and closed all the doors, ran around and slammed them all. And so that's nice. Typically, I'm going to design for worst case scenario, doors closed. But if you find when you're talking to your customer or talking to your users that the doors are typically open, well, maybe that's how you model the environment. So I'm going to say it depends. Use your judgment on that one. I think that's my answer there. Let's see. Ted has a question. Could you show how to locate an AP with a spectrum analyzer? Yeah, Ted, I can. Although the honest answer here is that spectrum analyzer, that's actually not going to be the tool for the job here. We're actually going to use either a site survey or a Wi-Fi scanner to do that. That's how we are going, and I think we'll probably make this the last question before we wrap things up here. So if we're going to do that with a site survey, when I conducted this survey, notice that it actually placed access points for me. So it detected an access point right here. Right now, the way that Ekahau does AP placement on the map is where signal strength peaks. It looks at where the signal strength is the highest for that AP, and that's where it puts the AP. So when you do your surveys, just make sure that you cover things pretty thoroughly, survey everything, and if you can see the access points, then walk directly underneath them, and Ekahau should place them perfectly accurately. So that's how you can locate it with a site survey. You can also locate it with Wi-Fi scanning as well. Let me show you the Wi-Fi scanner really quick. There is a signal strength over time graph, and you can see that line. Okay, here it is right here. There's not much going on here because I'm not moving around, but you would see this line climb up and then go back down, and that's where your AP would be if you're walking around. But really my favorite way to locate APs is do a site survey, and then Ekahau will place those on the map. Usually it's pretty accurate. Usually within about 10 feet or so is what I find. Just remember to do a nice thorough survey. The more thorough your survey, the better it will be. So, okay, great. Well, I'm going to go ahead and put my contact information up here on the screen for just a moment longer before we close out the webinar today. So if you have any further questions, if you have any questions that I didn't get to, or anything you'd like to discuss, please feel free to get in touch with me. Shoot me an email, or even better, reach out to me on Twitter. I'd be more than happy to engage there, and that's great because then there can be some public discussion with all the other great professionals out there. And so at this time, I'd like to go ahead and pass it back over to Latisa to go ahead and close out the webinar.
Great. Thanks so much, Joe. That was awesome. And thanks, everybody, for attending today's webinar. If you have any other questions, as Joel just mentioned, please feel free to contact him directly. You'll also receive a follow-up email within the next 24 to 48 hours, and we'll include a link to a recording of today's webinar. So again, on behalf of Ekahau, we thank you for joining and have a great rest of your day.